The REXA actuator interface with the plant's control system is the Local Control Enclosure, or PCP. The control enclosure receives a position signal and provides a position feedback to the plant's control system. Its other function is to position the valve as required by providing a drive signal to the actuator power module based on the position signal from the plant's control system compared to position feedback from the actuator cylinder. The REXA actuator is a closed-loop hydraulic system. It consists of the hydraulic cylinder, the power module, and the feedback module. The feedback module contains a potentiometer connected to the hydraulic cylinder. As the cylinder moves, it also moves the potentiometer, adjusting the signal from this device, which represents the position of the valve. The feedback board converts the potentiometer measurement to a 4 to 20 milliamp signal as the potentiometer changes position. The current will vary in relation to position. Once the actuator has been calibrated, the information from the feedback board positions, set at position low and position high, is converted to an analog 4 to 20 milliamp signal by the PCP to represent 0 to 100% position indication and correspond to 4 to 20 milliamp signal low and signal high default settings. The actuator is a double-shaft cylinder design, meaning that the shank goes through the middle of the piston, maintaining the same area on each side of the piston. This configuration results in the same volume of oil pumped to either side to position it, eliminating the need for any extra oil storage. The power module is the main component of the actuator. It contains the motor, gear-type hydraulic pump, and the flow match valve assembly. The powertrain components are fastened to a manifold. The manifold fastens to the power module block and contains two pressure gauges that monitor the extend and retract pressures. The gauges are used for troubleshooting and observation purposes and are isolated during normal operation to lengthen their life. The REXA actuator contains a small reservoir that provides an auxiliary volume for thermal expansion and contraction of oil as it heats or cools, depending on plant environment and operating conditions. The spring-loaded reservoir piston moves in and out along a level scale to indicate the status of the reservoir. This auxiliary volume also acts as makeup oil for the system in the case of a leak. The motor is a 100% duty cycle reversible unit which drives the internal hydraulic pump. The motor is either a stepper motor or servo motor. These motors are used because their speed and direction can be precisely adjusted by the control module to meet the performance required. The motor only activates when a valve position change is required, making it highly efficient. The hydraulic pump only generates the pressure required to overcome the load that the actuator is driving, making it even more efficient. The flow match valves are a unique pilot check valve flow control type design. The design allows for a constant oil volume to be moved back and forth from one side of a double-acting cylinder to the other. This happens in a smooth and stable manner regardless of the applied load or any load variations, including bidirectional dynamic loads from zero load to full actuator output. Unlike servo and proportional valves, the flow match valve does not require a constant pressure to be supplied to it. so continuously running motors, pumps, or accumulators are not required to maintain the valve position. The main parts of the valve are the spool and check valve assembly. Each valve provides alignment of multiple sets of ports for proper operation. In this instance, the main valve is required to close. The hydraulic pump will start, simultaneously supplying the bottom chamber as it draws from the top chamber. The top chamber is the supply for the bottom chamber and vice versa when the pump direction changes. The pump will displace the oil, simultaneously lifting the flow match valve spools and aligning the ports, depending on the direction of rotation of the pump. The actuator will move the connected valve in the direction that the cylinder drives it, based on which side of the cylinder oil is being transferred from and to. Once the valve reaches the desired position, the pump will stop, the flow match valves will return to their normal position, and the valve actuator will be locked in its current position. If the valve was required to move in the other direction, the pump motor will start in the reverse direction, causing the flow circuit to reverse in the mirror image. The actuator will move the connected valve in the opposite direction. Once the valve reaches the desired position, the pump will stop, the flow match valves will return to their normal position, and the valve actuator will be locked in its current position.